I know several are out with the cold weather today, so we're going to go ahead and proceed without them, just so we can stay on schedule to take our test next Wednesday. Today's topic, we're going to move now from the basic arithmetic, so no more operations, adding, subtracting, multiplying, dividing. Moving on to what we considered our first pre-algebra or algebra topic. And that deals with what happens when we have problems like this. 17 minus 3 times 4 plus 8. When we look at a problem like that, there are several ways we can interpret it. Some might say, well, let's just go left to right because that's how we read a book. That makes perfect sense, but it'll give a different answer than some of the other ways we might interpret that. And we have said there are different ways to do math, but there is only one correct answer. In this type of problem, some of the different possible methods would give different answers. So to ensure that when we do a problem, that everybody gets the same answer no matter what method they use, define something called the order of operations. A lot of people mistakenly think of order of operations as steps to solve the problem. It really is not a step-by-step process. What it really is simply levels of priority. Things that are on a higher level of priority have to be done before things that are on a lower level. So our highest level, something called enclosing symbol. Many of you have probably just been told parentheses, and that is definitely our most common enclosing symbol, but we will run into some others here as we go through example. Next, we have exponents. We briefly mentioned exponents. They include powers and roots. We have our third level of priority, multiplication. And of course, anywhere there's multiplication, there's division. Remember we mentioned they're really the same operation, just one's going forward, one's in. Then our lowest priority is addition and subtraction. So addition and subtraction only get done if there is nothing else that's higher priority to do. Now I should mention something called the simple order of operations. Because what's listed here is by no means all of our operations. We've mentioned this in the past. We have other pairs of operations like exponentials and logarithms, trig functions and their inverses. We don't get into those in this course, and they are there, but 99% of our problems don't involve those more advanced operations anyway. So we typically stick to this 4-level order of operations. There is a longer order of operations that includes those exponentials and logarithms and other operations in it, but it's beyond what we really need for most of what we would do. So then coming back over to this example, applying these rules, there are no enclosing symbols, so you can forget about that. There's no exponents, no powers or roots, so we're good there. There is multiplication and division. So what I do is I go into the problem, and I'm going to put a box around the first multiplication. There's only one in this problem, so that's the one I'm putting the box around. Then I do that calculation. 3 times 4 is 12. I replace the 3 times 4 with the 12. Everything that is outside of that box gets rewritten exactly the way it was. Now, I'm stressing that making the box and rewriting the problem because I found that there are more mistakes made rewriting the problem than there are just usually in the calculations themselves. So make sure you're very meticulous about rewriting the problem exactly and not missing or leaving any parts out. Now there's no more multiplication and division, so that's done. We can go down to addition and subtraction. Now there's both here in this problem. If there is more than one item on the same level of priority, then we do work left to right, just like reading a book. So here, going left to right, the first one we run into is that subtraction, 17 minus 12. Again, notice I put a box around the 17 minus 12. I'm going to do the calculation and replace the 17 minus 12 with 5. Everything that's outside the box gets rewritten exactly as it was. And then finally, we have 5 plus 8, which is 13. That all reduces to a 13. Not a terribly difficult problem, so let's step up to something a little bit more strenuous. Just a little more strenuous. That looks like kind of a monster of a problem, and it is a little bit. But as long as we follow our levels of priority, we'll come out just fine. Now I will stress, what I'm about to show you is only one way to approach this problem. But it's the most common way that we've been taught to approach this problem. So highest level of priority, enclosing symbols. We have several sets of parentheses. So as we mentioned, we're going to proceed left to right. So going left to right, the first one we see is this one here. Well, now we have to find its other end. So we go over. This one is facing the wrong way, so that's not it. This one here goes with that one, so we go to this one over here. That is the other end of that parenthesis. So now we're focusing inside that enclosing symbol, inside the parentheses, or the green box, if you will. Inside there, the order of operations still applies. Now again, highest priority is enclosing symbols. We see this parenthesis here, that's obviously an enclosing symbol, but one that's not as obvious is this one right here. That is a radical, or a square root in this case. It's separating part of the problem from the rest as well. It is also an enclosing symbol. So we can do that first. What we're going to do is actually just the inside of it. So let me box. We're going to do the 18 minus 2. 18 minus 2 is 16. So I replaced that 18 minus 2 with 16. And notice the rest of the problem is rewritten exactly as it was. Now here's why I stressed making my box around what I'm calculating and why I moved it, because that radical or square root symbol is outside of that box, so it is still in the problem. Now I have reduced what was in that square root to a single number. I'm done inside that enclosing symbol. I might be able to get rid of that enclosing symbol. I look outside of it, and I see that there are still things of higher priority, other enclosing symbols to do. Here, in other words. There, inside that enclosing symbol, I have 8 divided by 4, which is 2. I replace the 8 divided by 4 with 2, and I rewrite the rest of the problem exactly as it was before. Notice, again, the parentheses are still there, but it's been reduced to a single number inside that enclosing symbol. So again, we don't need it as an enclosing symbol. But these enclosing symbols often serve other purposes other than just the enclosing symbol. One of the things parentheses can do is they serve as they indicate multiplication. And here, that is, whenever there's a number outside the parentheses with no sign or operation there, it's implying or indicating multiplication. So that is 6 times whatever's in the parentheses. So to remove that set of parentheses, I have to remember that multiplication is there, and I have to put in the symbol to keep that multiplication there. Let's go ahead and take out those parentheses. 6 times 2. Notice we had to put in the multiplication when we removed the parentheses. Now we're still working inside that set of parentheses, inside that green box if you want to. In there we see there's no more enclosing symbols, but we do have a power or root. We have a root. This was an enclosing symbol before. As an enclosing symbol, we had to do what's inside of it. As a root, we have to do square root operation. Now, just like similar to the parentheses, those radical symbols do perform other tasks. They're enclosing symbols. They indicate a square root, but they can also indicate multiplication, just like the parentheses did. So, look here, we see the 2 in front of it. That is saying 2 times whatever the result of that root is. So we have to be careful to maintain that multiplication when we do the root. Now, to remove the square root symbol, we have to do the root. So the square root of 16 is 4. So we're going to take out the square root symbol and the 16 and replace it with 4. Everything else in the problem stays exactly the same, except that we have to put in that multiplication symbol as we remove the radical. Now we're still working inside that set of parentheses, inside the green box. Inside there, there's also more powers to do. 2 squared. Now, remember thinking I didn't go left to right. I could have, I maybe even should have done the 2 squared first. But as I mentioned before, order of operations is not, there's several ways to approach it. I approached this radical as an enclosing symbol that was done that I could get rid of. So I did the root to get rid of the enclosing symbol, rather than necessarily approaching it as an exponent. If I was approaching it as an exponent, I probably should have done the 2 squared first. Notice the result is going to end up the same either way. So 2 squared is 4, 2 times 2. Problem stays the same. Well, we're still working inside the parentheses. We will keep working inside that same set of parentheses until we've reduced it to a single number. No more radical, or no more powers or roots, no more exponents. So we're down to doing multiplication and division. There's several multiplications here, so I go left to right. 5 times 4, which will be 20. Now you'll notice there's a lot of rewriting here. I've taken up a lot of space already doing this problem. There are shortcuts. As we said, it's not an absolute single method. I could have done, since they're separated by additions and subtractions, I could have done each of these multiplications all at the same time, replacing all of them in one step. I didn't do it because there's sometimes where that won't work. But here, this 2 times 4 would be my next step. That's my next multiplication going left to right in the parentheses. But since this is disjoint, there's nothing that would affect doing the 6 times 2. Let's do it at the same time. 6 times 2 is 12. Everything else in the problem stays exactly the same. So again, the reason I was able to do both of those at once is they were separated by an operation with lower priority. So there was nothing that was going to happen between those two items until the multiplication was complete. So we could do them both at the same time. So still looking inside this set of parentheses, we're down to addition and subtraction. Now addition and subtraction pretty much does have to stay left to right. There aren't any really many shortcuts here. 37 minus 20 is 17. (17) plus 8, 5. And now finally we're down to 25 minus 12, which is 13. Now again, I'm going to combine two steps into one here. I've reduced what's in that enclosing symbol to a single number. So I'm going to do the operation to reduce it to that single number, and I'm going to remove the parentheses at the same time. Once again, though, I have to double check to make sure that parentheses is not doing anything else. Here it is. It's indicating that it's being multiplied by 3. So when I take out that parentheses, I have to put in that multiplication as 3 times the 13 from in the parentheses. Now here, finish that set of parentheses. So we look back out for the larger problem. We have, or another enclosing symbol. So we do the 5 minus 2. Technically, we do what's inside there first, and that's 3. But we've reduced that parentheses to a single number, so we can take it out. Again, we look to see if that parentheses is doing anything else, and in this case, it is not. There's already an operation in front of it, and there's nothing behind it, so that parentheses is not indicating anything else. So we can just go ahead and take it out and rewrite the rest of the problem as it was. No more enclosing symbols, no exponents. We only have one multiplication or division left. 3 times 13 is 39. And now it's just the addition. Eight plus 39, 47. And 47 plus 3. I'm going to go back here and point out the most common mistake made in this problem. And I hesitate to do that because I don't want to draw your attention to it and get you to make the mistake unintentionally. But notice one of the last things that was done at the bottom of this problem, adding to the 8. Biggest mistake, the most common mistake people make is they see this 8 up here, and they see 8 plus 3 and think, let's just add that and get 11 first and get it over with. But we can't. Remember, we're dealing with levels of priority. So if we're looking at the 3 has 2 things happening to it. The 3 is being added to the 8, but it's also multiplying the parentheses, which has a higher priority than multiplication. So that 3 cannot be added to the 8 until it is multiplied whatever's inside the parentheses. It has a higher priority on its back side. It has to do that multiplication before it can do the addition. Let's look at some other examples. something like this. When we look at this problem, T is figuring out what this line across here. Now, most people would yell out division, and it does mean division. That line is called a fraction bar, and it does indicate division, but it is also an enclosing symbol. It separates the top of the problem from the bottom of the problem, which is saying that we have to do those two pieces separately. Then we divide. So we'll do the top first. I'll rewrite it off to the side here, so I have room to do it. So in that expression there, no more enclosing symbols, but there is an exponent. Square root of 4, which is 2. Next, there's multiplication and division. We will work left to right. 7 times 11 is 77. Now this is another case where we could have done the division in the same step because they're separated by a minus. I just didn't do it this time. 58 divided by 2 is 29. And we have 77 minus 29. 48. Top of that reduces 48. Now we have to do what's on bottom. On bottom, again we have an exponent, power. 3 squared is 9. $35 divided by 5 plus 9. No more exponents, but we do have division. 5 divided by 5 is 7. And finally, all that's left to do there is 7 plus 9 is 16. So the bottom of that reduces to a 16. And of course, we'll have to combine those by dividing. 48 divided by 16 is a little bit of a warning about your calculator. As ugly as this problem up here appeared, actually a very simple calculator problem. I just enter this problem in the calculator exactly as it appears there. Eight plus 3, parentheses, 5, 2 squared times square root of I have to do a little bit of adjusting because of the square root symbol on this calculator. You'll notice I get the exact same answer. Just had to enter it in. The reason is this is a single line problem, all in one line, linear. This one down here, even though it looks way simpler, is way more complicated to enter into the calculator. I have two choices. I can either add a bunch of parentheses to make the calculator do this correctly, or I can just do it in 3 steps. What do I mean? Well, I can do the top first. If I punch in 7 times 11 minus 58 divided by the square root of 4, it'll give me 48. Write that down, do the bottom. If I just punch that in, 35 divided by 5 plus 3 squared, it'll give me 16. Then I can divide them. So if you're using the calculators, most of the time for these, it's easiest to do the top first, then do the bottom separately, and then divide those results, rather than trying to enter it all as one entry. Now, if you have one of the fancier calculators, some of the newer Texas Instruments, when you enter, you can actually enter a fraction and then enter all the stuff on top and all the stuff on bottom as a fraction. That's wonderful. Those work great. But you don't need that fancy of a calculator to do this correctly if you split it up like that. let's do something like so we've hinted at this a little bit earlier. This symbol here, the square root symbol, is what we're used to calling it. It's technically called a radical because it can signal other things other than a square root, other roots. But again, it's also an enclosing symbol, so we have to do what's inside of it here first. So inside there, no other enclosing symbols, there's an exponent, there's a power. 3 squared, which is 9. Replace the 3 squared with 9, everything else. There. Still working inside that radical or inside the root. Multiplication would happen before the addition. So we do the 7 times 9, 3. Next, all that's left to do inside the radical, the addition 1 plus 63 is 64. Now we have reduced that root to a single number inside of it, so we can get rid of it as an enclosing symbol. We look outside of it, there's nothing else that has higher priority, so we can go ahead and do the square root. But again, we have to remember that it can do other functions, and here it is also indicating multiplication. It's 3 times whatever the result of that root is. So we're going to have to remember to put in that multiplication when we remove the square root. Also, unlike the parentheses where we just remove them and we're done, when we remove the square root, we have to do the calculation. Square root of 64 is 8. Next, we only have the addition and multiplication left. Multiplication is higher priority. So we do 3 times 4 is 24. And then lastly, addition, 11 plus 24. One of the reasons I use this example is this is an example where we actually do start at the end and have to work our way backwards because that's just how the levels of priority fall. Whereas in most of the time, we try as much as possible to work left to right within that order of operation. We've worked with fractions and decimals, and those fit into these order of operations. The most common application for fractions is something they refer to as complex fractions. You might have something like 2 1/3 times, of course, divided by 1 1/2 plus 1 1/8. Now again, if you have a fraction calculator, this isn't so bad, but I would still recommend you do it in those 3 steps. Do what's on top, then do what's on bottom, then divide those 2 results. Which is actually the same process we're going to take doing it by hand here. Let's do what's on top. I'll write it over here. 2 1/3 times 3/4. Remember, when we multiply fractions, if there's mixed numbers, we're going to change them into improper fractions. So 2 times 3 is 6 plus 1 is 4. We're going to cross cancel here. The 3's can cross cancel. Both divided by 3. 3 divided by 3 is 1 in both cases. Then we multiply. 7 times 1 is 7. Times 4 is 4. That is 7/4. Now, if this were the end of the problem, I would reduce that down to a mixed number of 1 3/4. But I know there's another step coming, so I'm going to leave it as 7/4 for now. Next, I want to do the bottom down here. I'll write that off to the side as well. 1 1/2 plus 1 7/8. Now, I'm used to doing my addition vertically, so I wrote it vertically. I need common denominators. So the whole numbers, the ones aren't going to change. For 2 and 8, my common denominator is 8. So the 8's going to stay 7/8. That hasn't changed. 2 is multiplied by 4 to make 8, so I do 1 times 4 is 4. Then we'll go ahead and add. 4/8 plus 7/8 is 11/8. Well, that's an improper fraction, so let's go ahead and break that down. 11/8 is 1 3/8. So I will keep my 3/8 and carry my 1. 1 plus 1 plus 1 is 3. This is 3/8 for the bottom. Now I have to divide that. So I have 7/4. And remember that fraction bar means division, so it's just divided by 8. Now I left the 7/4 as an improper fraction, so I don't need to change that. But I do have to make the 3 and 3/8 into an improper fraction. 2 times 8 is 24, plus 3 is 27, so 27/8. Still division at this point. Division then, I multiply by the reciprocal. Remember, the first fraction doesn't change. The division operates on the number that comes after it. That becomes times the reciprocal of 27/8 is 8/27. Now here we can cross cancel. The 4 and the 8 both divide by 4. 4 divided by 4 is 1. Divided by 4 is 2. Then we'll multiply. 7 times 2 is 14. 1 times 27 is 27. There's our result. 14/27 is the result of that problem. We'd have one like this: 2 1/3 plus 3/4 times parentheses 1 1/2 minus divided by. Don't want to get too much longer than this because when we deal with fractions, those denominators can compound rather quickly and give us some really large numbers. So here we have the parentheses. We're going to start inside there. Inside there we have addition and we have division. Division has a higher priority, so we're going to do that first. Now the biggest difference here between this order of operations and what we were doing for examples at the beginning with whole numbers, the steps are exactly the same. It's just a little more complex combining the numbers. I could do all my other multiplications and stuff in my head for the whole numbers. For the fractions, we can't. So we're going to have to write it out. Thirds divided by 2 3/5. That improper for both of them. 6 times 3 is 18, plus 2 is 2. Divided by 2 times 5 is 10, plus 3 is 13/5. Now it's still division, so I can't cross cancel yet. Keep the 20/3 and make it times 5/30. This is where I would be able to cross cancel if it were possible, but it's not here. Now I go ahead and multiply. 20 times 5 is 100. 3 times 13 is 39. You can see we got an ugly denominator already. And we'll go ahead, since we're going to add that to 1 1/2, let's go ahead and reduce that to a fixed number. 100 divided by 39. 39 goes into 100 twice. That would be 8. Over. So, thirds divided by 2 3/5 reduces to 2. Nice. All that's left inside the parentheses is to do that addition. We'll write that off to the side. Half 2 and 22. Well, looking at 2 and 39 and trying to find a common denominator is a little bit of a stumper, but remember, we can always just multiply them together. 2 times 39 is 78. That actually is our least common denominator in this situation. 2 is multiplied by 39 to make 78, so 1 times 39 is 39. 39 is multiplied by 2 to make 78, so 22 times 2 is 44. Go ahead and add. 39 78ths plus 44 78ths is what? 83 78ths, which is 1 and 5 78ths. So I keep my 5 78ths and I'll carry my 1. 1, 1, and 2 make 4. So what's in my parentheses reduces to 4 and 5 78ths. So not only have I done the addition, but I've reduced the parentheses to a single number. So I can take it out, remembering to put in multiplication, because that parentheses is indicating multiplication there as well. Next, I have the multiplication here, 3/4 times 4 and 5/8. 5 78ths, I should say. This one's going to get a little bit large because I have that large denominator, 78ths. 3/4 won't change. It's already just a fraction, but I have to do the 4 and 5 78ths into an improper fraction. 4 times 78 is 312, plus 5 is 317 eighths. Now let me double check this quick to make sure. 4 times 78 is 312. Good. Now, at first glance, you might not see any cross-canceling we can do. But remember, if you add the digits of a number together, here's 7 plus 8 is 15. If that's divisible by 3, the whole number is divisible by 3. Well, 15 is divisible by 3. So both 3 and 78 can be divided by 3. 3 divided by 3 is 1. 78 divided by 3 is 26. Now we go ahead and multiply. 1 times 317 is 317. 4 times 26 is 104. That reduces to 104 goes into 317 3 times. 3 times 104 is 312. 5 left over. That's 3. 5 over 104. 2 and 1/3 plus 3 and 5 over 104. All that's left to do is the addition. All that's left to do, but that's an ugly common denominator. Let's slide down. 2 and 1/3 plus 3, 5 over 104. Again, ugly common denominator. Rather than trying to figure out what would be the least one, I'm going to go ahead and just use 3 times 104 is 312. So 3 times 104 was 312, so 1 times 104 is 104. 104 times 3 to make 312, so 5 times 3 is 15. And 104 plus 15, 19. 112. And then 2 plus 3 is 5. Now we should look to see if 119 and 312 can reduce. They cannot. Here's our result, 119 over 312. 5 and 119 over 312. So I won't be quite that mean to you on a test, but I would do one like this first one here with the compound fractions. That's fair game. And of course, the whole numbers, there'll be a few whole number order of operations on the test as well. So remember, Unit 1 test is coming up next Monday. That'll be next Wednesday. That'll be February 2nd. I will send that out either later today or tomorrow to your contact person at your location, so they'll have them. To practice this order of operations that we did today, page 23 in the book, 1 through 21, the odds. Normally I say skip over some of the first ones if they're simpler. There's not a lot here. There's only 11 problems here. So please do them. At least definitely do the harder ones at the end. But a little bit smaller assignment today. With that, does anybody have any questions? Okay, well, you all have a great day. Hopefully we'll see you all on Friday.